In this lecture, we're going to talk about clean code. Clean Code is a book written by the pioneers of software engineering, and it is about how to write a code that is easy to read and also easy to maintain. In the next few slides, I'm going to mention some quotes by some of the people who helped write this book. Throughout this lecture, I'm going to try to point out to the most important points that are indicated in this book. But I encourage you to read the book completely if you are interested in becoming a software developer and if you're interested in knowing the standards for writing clean code in the industry. Leave your code better than you found it. It means that if you are working on a code and if you see something that could be written better, try to make that code better. You are going to make life easier for yourself and anyone who is going to look at that code later on. I like my code to be elegant and efficient. Clean code does one thing well. So pay attention that when you are writing a code, you want it to look elegant and you want it to be efficient. And in order to have a clean code, you need to make sure that you're only focusing on doing one thing and you are focusing on doing it well. Clean code is simple and direct. Clean code reads like a well-written prose. So you actually want to be able to read your code like a book. That's why it's important to use meaningful names for your variables, classes, or any other object that you use. So anyone, by just looking at your code, by literally reading your code, can understand what you are trying to do. Clean code can be read. Clean code should be literate. Clean code always looks like it was written by someone who cares. So that's very important. When you are writing your code, when you want to have a clean code, it's not just about getting the job done. It's about making your code presentable, making your code readable, and making your code easy to understand for anyone who looks at it later, including your future self. Reduce duplication, high expressiveness, and early building of simple abstractions. So these are some important points. You don't want to have any pieces of code that is copied and pasted to a different part. If you are doing that, you're doing something wrong, and you need to use methods or classes or any other type of abstraction. You want your code to be highly expressive, and you also want to think of abstractions beforehand before you actually start coding. So it's important to think about the design of the program you're going to develop before starting coding it. You know you are working on clean code when each routine you read turns out to be pretty much what you expected. Again, this points out to the importance of your code being readable to help people understand what your code is supposed to do by just reading it and not having to compile it or debug it or do any more extra work just to understand what a piece of code that you wrote means and what it's supposed to do. So this actually comes directly from the book. The only valid measurement of code quality is WTFs per minute. So the goal isn't to have a perfect code because such a thing doesn't exist. But the goal is to reduce the number of WTFs that people have when they look at your code. In order to do that, one of the key things is to use meaningful names. You want to use intention revealing names. For example, instead of using some general variable names like list or get them for your method, or list1 or the list or x, they don't have any meanings. It would be much better to use names that actually mean something. So for example, this piece of code does the same thing as this one, but now the names are more telling. The name of the method is getFlagSelled, and the name of the variable is flagged cells. And now we know that we are working on a game board and we want to access different cells of that game board. This code is much easier to understand than this one. We want to avoid disinformation. Again, the naming can help give context to your code so anyone who reads your code can understand. These two pieces of code do the same thing, but now we are defining a method and we give it a proper name. And that makes it more clear what this piece of code is doing rather than having just a bunch of letters in shape of a code. Use pronounceable names. We don't need to shorten any names that may be hard to interpret or read or understand what they are. For example, the class name could be customer, or you can just spell out generation timestamps. That is much easier to understand than like Gen Y MD HMS. Use searchable names. So when you want to look for a variable, you're not just looking at random words or letters. You know exactly what you're looking for and you can find it in your project. Avoid prefixes, avoid using any special characters. Just spell out the name of the variables, the name of the methods. Avoid Hungarian notation. So in older programming languages and in older ways of programming, it was a common practice to mention the type of a variable in its name. So for example, if you save your phone numbers as a string, then you would name the variable phone string. This doesn't apply to the modern programming languages because it's easy to just use the IDE to know the type of the variable. So now, also considering the fact that it is possible to change the type of a variable later on, we don't want to associate any type to the name. So if you want a phone number, we can just use whatever name that is, like for that phone or for that phone number, and we don't need to mention the type of that variable. For class names, we want to make sure that we are using nouns and not verbs. However, for method names, we want to use verbs because methods are supposed to do something for us. And we want to make it clear what is it that this method is going to do for us. Also, make sure that you're consistent. Just pick one word for a certain act and use the same word throughout your code. For example, there are different options for fetching something. You can use fetch or get or retrieve or many other words. Or for some of the applications that you have, you may want to use controller, manager, driver. Just be consistent with it. Pick one and be consistent with it. When writing methods, you need to follow two rules. The first one is that methods should be small, and the second one is that methods should be smaller than that. So think of the smallest possible method that you can write. You want to separate different tasks and put them in separate methods. You can call multiple methods inside another method, but avoid having long pieces of code in one method. For each piece of code, think about what the functionality of it is, and if you can put that code in a method and call the method instead of just copying and pasting that code. We can also use the techniques in object-oriented programming to avoid long switch case statements. For example, by overriding a method from a parent class, we can avoid long conditionals like the switch case here. So this piece of code is doing the exact same thing as this switch case, but this is cleaner and this is also following the principles of object-oriented programming. When writing your methods, make sure that your methods have no side effect. That's why you want to have small methods. So they only do one thing for us, and they do that one thing well. The goal of writing clean code is that your code is so easy to read that you don't need comments. So, in the view of clean code, comments are a failure to express ourselves with our code. And that's because comments don't age well. Over time, code changes, but comments don't. And they result in comments that lie and are giving misinformation. So, it's important to avoid comments, and if we feel like we need to put a comment for a piece of code, it means that we didn't write our code very well, and we need to rewrite that code and make sure it's very expressive. So whenever you feel like you need to write a comment, always try to think of an alternative. Maybe you need better names. Maybe you need to make more granular methods so you can see the interaction between different objects and different methods with each other. And maybe you need to create more well-named constants. For example, instead of having a bunch of variables, for example, flag or hourly flag or employee.age, um, instead of doing this logical calculation here, you could just create a method and call that is eligible for full benefits. So now all of that calculations is happening inside the method, but whoever is reading your code, they know what is exactly going on and they don't need to understand what each of these variables are about and what they do. We do have some good comments. For example, we have legal comments that are required for certain applications in certain companies. We also have to do comments. They even come up in IDE to remind you. So you can have a comment for something that you need to do later. And if you use to do comments, you can actually use the IDE to remind you of all the things that needs to be done in your code. There are also rare cases of writing a comment about warning for some consequences. For example, if a method is not thread safe or it can cause a race condition, you want to write a method and explain that rather than having like a very long name to explain the problem. These cases are very rare and you probably won't face them during this class, but that would be a reason to have a comment and wouldn't interfere with clean code. Formatting is also important to make your code more readable. Good formatting means effective communication. So vertical openness is important. For example, use a blank line to give visual cue for a new concept, for example, between different methods. Modern IDEs can auto-format on save, and you are going to use that during this class to make your code look better and easier to read. You also have to make sure that you follow team rules when you are working with a team. There are certain formatting that you might prefer, but when you are working with a team, it's the team rules that you need to follow, not your personal preference. To have a clean code, you want to do your error handling properly. So you want to throw exceptions for anything that might go wrong, for any error messages that you might have. You want to have proper exceptions. Don't just return the error codes that your IDE gives you or the compiler gives you. Extract try-catch blocks into their own methods. You shouldn't do the try-catch inside a method because you end up doing two things inside a method and you're only supposed to do one thing. Also, avoid returning null because that can break everything. Inside the classes, there is an order for variables and methods. So when you're writing a class, you start with public static constants, and then you have private static variables. You have private instance variables, and then comes your methods, with public methods coming first, and then private methods. Keep in mind, that you use the same rule for classes as you did for methods. Classes should be small. Classes should be smaller than that. Try to make your classes as small as possible. Have as many objects as possible and make sure that they interact with each other rather than having just a few but very large objects that do a lot of things. Do not repeat yourself. Duplication is the root of all evil. Whenever you find yourself copy and paste something, it means that you're not doing your coding right. Think of a method that you can probably use. Think of abstraction. Think of different techniques that you learn in object oriented programming and try to use them. Never copy and paste your code. There's also the principle of Yagni. You aren't going to need it. Always implement things when you actually need them, never when you just foresee that you may need them. So whenever you're developing something, only write a code that you're immediately going to use. Do not worry about the future. Do not predict the future. You can write the code for future when the time comes. You don't want to write too many lines of codes that you may not end up using. Try to minimize waste and maximize time, but not wasting time. For example, you don't need to write getters or setters for all of the variables inside a class. Think about the different type of interactions that those variables are going to have and whether you need to have getters and setters for them. Also, about deleting. Unused code is a maintenance cost, both now and in the future. Unused code makes refactoring more difficult now. If the code isn't used to provide business value now, delete it. Don't be afraid of deleting a code that you're not using. If you need it later, use version control and you can go back and bring that code back. So, in conclusion, remember that your instructor and your TAs are going to grade your code. So, the more readable your code is, the better it looks. You are going to give them an easier time. And if they have an easier time, they are probably going to give you an easier time. These are the expectations for this class. So, you need to make sure that you follow the clean code principles. And in the end, I strongly recommend you to read this book, especially if you are considering a career in software development world.